I hope everybody is fine, and and uh, I welcome you all, and let's try to learn together more as we proceed on discussing the nature of reality, the reality of quantum mechanics, uh, the quantum mechanical laws, the quantum mechanical provisions that we are trying to connect with the biological systems. So, in continuation to our previous understandings, in continuation to our previous learning, uh, today we will take on this journey. We will take on this journey towards more fundamental nature of reality that connects biological systems to the basic laws of physics, to the basic laws of physics in the framework of quantum mechanics, and it will be just profound physics, biology, and 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 of course thinking clearly. So how should I know down this thing is we will be talking about time, irreversibility, and living systems. So time and irreversibility and uh, and the living systems. So this is what we will be talking about, irreversibility. I'm not able to write it clearly. Okay, so you can see it. So we will take our learning. We would like to understand. We would like to have some understanding over this factual position. And before we talk about the life here we say life in terms of the biological systems, and similarly before we talk about the atoms and molecules, and before we talk about the memory that leads us. What is important is that we must talk about time. And then automatically these irreversible nature of time can be demonstrated. This is because life does not merely exist in time. You cannot say that it exists in time. What's happening here is it's like life is written by time. The time is writing life. And once the life is written, and once the life has been put into the codes, once it is written, it cannot be erased. It cannot be erased. So, the foundational question, the fundamental question, the fundamental query is that why does every living system remembers its past? So the systems that we have, they remember their past, but they never do the same thing for the future. And why can life grow? Why it ages? And why there is decay? But there is no, or I should say, but there is never any kind of reverse. This is the argument. This is something that we are going to talk about. And we are not going to talk about the philosophy of these kinds of things. We are not going to talk about it in a metaphorical sense, as I repeatedly say, but we are going to talk about this argument in the framework of the physical laws, the laws of science, the laws of physics, and more precisely, in the framework of the laws of quantum mechanics, and what we call as the arrow of time. An arrow of time. Now, at this arrow of time, we would like to understand at a fundamental level, at a very basic level of science. Most equations that we have in physics, they are time symmetric. Their nature is symmetric. The examples are the Newton's laws of physics. These are symmetric equations with respect to the time. Then you have Maxwell's equations. They are symmetric equations with respect to time. Even the very foundation of quantum mechanics, the Schrodinger's equations, they do not care. They don't care whether time moves forward or backward. They don't actually care about the arrow of time. Formally, what they do is they replace, you replace with the equations, if you replace the equations, they still hold. So why does the direction of time come from? If you replace the time from the equations, these equations still hold. Say, for example, if I take an example of the entropy, entropy defines a direction. What it defines the arrow of time. The arrow of time is not written into the motion. But there is an arrow, there is a degree of disorder going in some direction. But this is written in the form of that disorder. It's written in the form of entropy. And to go with second law of thermodynamics, what we have the second law of thermodynamics, and what it states, what it tells us that in any closed system, an ideally closed system, entropy tends to increase. Now you can see here, you can realize here that it's not basically about the order. It's not about the disorder. It's about the irreversibility. It goes on. It won't come back. It goes on for an ideally closed system. Now, why this matters for life? Why we are trying to understand it in the framework of life, and why it matters at all. Living systems, they are not closed systems. They are open systems. What they do is they maintain the low internal entropy. That's what they do. They are not closed, they are open, but they maintain this stable internal entropy. And how do they maintain that? They maintain it by exporting entropy to their surroundings. Okay, so they export that disorder to the surroundings so that there is order inside there. But the total entropy of the universe always increase. The total entropy with respect to the surroundings always increase. So life survives locally. It survives locally by maintaining that balanced entropy, by paying a universal price. So what we can say here, entropy, talking about time, the time moves forward. Now, how we say that time moves forward? Because entropy never fully returns. So if entropy does not fully return, that's why the time is moving forward. Now let's try to understand it with an example. Take an example of a broken cell. You have a broken cell. Now, to understand this, let's consider a living cell. You have a living cell, okay? What a living cell does, it maintains its structure. It maintains its shieldings, what we call as membranes. It maintains the variations, the gradients of time, the gradients of pressure. It maintains an organized chemistry within it. Now, if this cell dies, what happens? If the cell dies, its structure, it collapses. It collapses. It formally collapses. No natural biological process resembles it. Why? Because reassembling would require entropy to spontaneously, it would require the entropy to spontaneously decrease. And that doesn't happen. When that thing doesn't happen, this is why life cannot run in the backward direction. This can be a pure scientific argument for the death. This is not the limitation of the biological science. This is not the limitation of the biology itself. This is the impossibility. This is basically a physical impossibility that cannot be attained. Now, to reverse life, what life would do is, life would require exact molecular reposition. It would require the same kind of repetition. It would require, I may call it, a perfect energy recovery. Zero loss of information. Zero information loss. None of these are always allowed by thermodynamics. None of these things are allowed by the laws of thermodynamics. Life moves, it moves forward. It moves on. And why it moves on? It moves on because the laws of physics forbids the retreat. Let's go deeper into this idea. Now, let's think about this irreversibility at the very quantum mechanical level. Now we realize what quantum mechanical level is. A level of those particles. And quantum systems evolve, but they evolve reversibly until measurement occurs. They evolve reversibly until you are making an act of measurement. Now, before measurement, what exists? There exists superposition. So, the life has many states before you are making any kind of an act of measurement. So, before the measurement, information is conserved. And after you make an act of measurement, your outcome is fixed. You have just one outcome. How can I take it on? Alternatively, all other alternatives that exist in that reversible process, they vanish at the time of making a measurement. This is what we call in quantum mechanics as the measurement problem. And quantum measurements, how can we make an act of their resemblance as a time marker? What measurement basically does, when you make an act of measurement, it breaks the symmetry of the system and it selects one outcome, just one outcome from infinite number of possibilities, or from many of the possibilities that could have been there. And all of these possibilities that could have been there, they could have been there mathematically. Now, once this happens, once you make an act of measurement, the prior superposition cannot be recovered. The superposition that existed there before the act of measurement, you cannot recover that. This is a point of no return. You cannot go to that state of superposition of your system once you make an act of measurement. Now, how can we have a biological interpretation of this argument? Can we connect it to the biological systems? Now, every biological interaction that's going on, it acts like a measurement. So any kind of biological thing or chemistry that's going on, everywhere these are the acts of measurements. Molecular bindings, they are the acts of measurements. Chemical reactions going on between the atoms are acting as the acts of measurements. And there is transfer of energy. The energy transfer from one system to another system to another system, they are coming as a result of these acts of measurements. And each one selects an outcome of the infinite number of states that are available to them. Erasing all the alternatives and choosing just one. Choosing one records the history. So life is a continuous sequence. It's a continuous, it has continuity in it. It has a continuous sequence of irreversible measurements going on and on. It's so strange. It's so amazing. Let me take you to another example as we are using as DNA replication, the replication of deoxyribose nucleic acid. Now, what happens when DNA replicates? What it does, DNA replicates, base pairing is selected. Hydrogen bonds settle, and you have a configuration, and configuration locks in. This process is a directional process. The process is purely directional. The molecule, the DNA molecule, what it does, it remembers what happened. It has that act of memory that what has happened. And replication cannot be undone. It cannot be undone without destroying the molecule. Now, what does it leads us to is that it cannot be undone. That is irreversibility in action. So I can say that biological history is a set of sequence, is a set of events. It's cumulative. Living systems do not reset. They don't reset. What they do basically is they accumulate. What they do, they accumulate molecular changes. They gather the molecular changes. They make an aggregate of molecular changes. And there are structural modifications. And once there are structural modifications, there are the decisions, and these decisions are energetic decisions. And each step depends on the previous one. Now, what does it do? This creates the biological history. It gives you an historical account of biological actions that are taking place in your body. So what we can say, can we boil down it? We can boil down it to memory written in matter. Memory is not an abstract thing. It's not an abstract thing that we have in a computer which is purely working on classical laws of physics. Memory is physical. Now, in biology, memory exists. Memory exists in the form of molecular conformations. They act as the steps of memory in the biological systems. What they do, they create the chemical marks. They create the signs of chemical marks. There is structural rearrangement. The structural rearrangement goes on and on. And once a memory is written, these changes influence all future behavior, all future events, all future actions. Now let's take the same argument to the proteins, a very native kind of problem in the field of biological science, what we call as protein folding. A protein folds into some specific orientations. It does not take up any orientation. They fold in some specific quantized orientations. That shapes determine its function. These shapes that they form. Now, once they are folded, the pathways change. Once they are folded, the reactions alter. The reactions are modified. The interaction is shifted. The interactions shift. The folding history that this molecule has, the folding history that this protein has, it becomes encoded in its structure. The past remains active. It doesn't die. So if I take on time, so what time I can put here? Time is a constraint. It's not a background of an action. It's a constraint. It's the restriction. Time is not just a parameter. A parameter in your equations, putting the value in seconds, in seconds, minutes, hours, light years, whatever. For living systems, time is always a constraint. What it does basically is it limits what can be reversed and what can be corrected and what can be replaced. Life must operate. It must be operational in nature. Now, under reversible conditions, what will we expect? Under reversible conditions, life must go on and on. So if we think from quantum possibility to the biological fact, what can be the argument? Now, at the quantum level, because your biological system is already existing in those quantum levels, at quantum level, there are many futures, multiple, infinite number of futures exist. At the macroscopic level, I mean at the biological level, at the classical biological level, only one past exists. This is so beautiful. This is so surprising. This is so astonishing. The transition occurs through these interactions. The acts of measurements. One molecule is making an act of measurement on another, on another, on another, on another. And these acts of measurements are constructing your present. They are constructing your past. And what in general is happening? Entropy increase. Once crossed, there is no return. There is no returning back. Now let's try to make a formal argument about this. Let's have a formal statement. Let a system pass through the states. You have a system, it goes via different states. Now, if entropy increases at every level, at every state, at every step, then the reverse path is forbidden. You cannot go back. It's impossible. You cannot go back. Biological systems operate exclusively. They exclusively operate along such paths, along such irreversible, I may use a wrong word, but I have to use it, the irreversible trajectories. Because in quantum mechanics, we don't have trajectories. Now, why life requires irreversibility? Why it needs this reversibility, which we have been talking about for the last 25 minutes. Without irreversibility, there will be no memory. There will be no memory. There will be no accumulation. You will not have those frames of memories in life. They are coded. There will be no persistence. Persistence going on and on and on. A reversible life, if life is reversible, it would forget itself. So life exists because the past remains real. That is the argument. The life exists because the past is real. If there is no past, there is no life. If life knows the reversibility, there is no memory, there is no life. Time is not an enemy of life. Time is the signature of life. It's the coding of life. It is the signature of the life. Now, every molecule remembers where it has been. And to move a little bit ahead of it, every cell carries its own historical account. Every cell carries its history. Every living system is itself a record, is itself a register of irreversible events. And these irreversible events are written into matter itself. These events are written over these atoms and molecules itself. So life, it moves forward. And it carries that long chain of historical events. Because the universe doesn't. The universe as a whole can be thought as alive. And once written, that story cannot be rubbed, it cannot be reversed. Okay, with this, I would like to stop this today's argument. I hope you like it. I hope you subscribe. And I wish all the best to everybody. And I love you all. Goodbye.